Hello and welcome back to another video. Here we are going to discuss the last four questions, that is 9th, 10th, 11th and 12th from October November 2020 970911, that is pure mathematics 1. We have solved the previous questions in the last videos, and here we are going to discuss the first question, that is 9th. And here's the question number 9. The diagram shows a circle with center O passing through B. A second circle has center B and passing through A. The tangent at B to the first circle intersect the second circle at C and D. The coordinates of A are -1, 4 and the coordinates of B are 3, 2. So we have the coordinates of A as -1, 4 and coordinates of B as 3, 2. Find the equation of tangent CBD. We need to find the equation of this tangent, that is we need to find the equation of line, and we have one point on the line, so we can use this formula to find the equation of line, that is y minus y1 is equal to gradient times x minus x1. So we require the gradient of the line CBD, and we know that the at this contact point, the angle between radius of a circle and the tangent is always a right angle, so it is going to be 90 degree. So all we need to get the gradient of AB. So if we have the gradient of AB, then gradient of CBD would be the negative reciprocal. So gradient of AB is equal to y2 minus y1 upon x2 minus x1. So 2 minus 4 over 3 minus -1, that is +1, because it is minus, and it becomes -2 over 4, that is -1 over 2. And hence since it's the gradient of the perpendicular line would be negative reciprocal, so the gradient of CBD is going to be 2, because it is -1/2, so it would be 2. And hence the equation is going to be y minus y1, that is I'll take 2 because it is the point passing through the line is passing through this point, so y minus 2 is equal to gradient times x minus 3, and we can leave our answer till here also, otherwise we can solve. It is going to be y is equal to -2 here, that would be going the another side, plus 2, so 2x minus 6 plus 2 is -4. So that is the equation of tangent CBD. Let's do the B part. Here's the B part. Find an equation of the circle with center B. So we have the center B as 3, 2. All we need to get radius of a circle, so that we can use the formula x minus h whole square plus y minus k whole square is equal to r square, where h and k are the coordinates of center and r is the radius of circle. I'll bring the diagram here so that it will be clear. So we have coordinates of A -1, 4, coordinates of B 3, 2. So this AB would be the radius of the circle with center B. So radius r is going to be the square root of difference of x coordinates square, that is -1 minus 3 whole square, plus difference of y coordinates 4 minus 2 whole square, and hence it become 4 square is 16 plus 2 square is 4, and hence it become root 20. So the equation of circle would be x minus 3 whole square plus y minus k, that is 2 whole square, is equal to r square, so it would be 20 only. That's it. Let's do the C part. Find by calculation the x coordinates of C and D. We can see that C and D are the point of intersection. So whenever we have the point of intersection, we solve the simultaneous equations, and in this case we have two equations, one as the equation of tangent, that was y is equal to 2x minus 4, and another is the equation of circle, which we have just got. So now if we solve for these two, we will get two values of x, two values of y, and we only require the two values of x. So let's solve this simultaneous equation. So y is equal to 2x minus 4, and another one is x minus 3 whole square plus y minus 2 whole square is equal to 20. I'm going to substitute this value in this, so it becomes x minus 3 whole square plus y in place of y, I'll write 2x minus 4 minus 2 whole square is equal to 20, or we can write it as x minus 3 whole square plus 2x minus 6 whole square is equal to 20. Now we can see this 2x minus 6 is actually x minus 3 into 2. So we can write it as x minus 3 whole square, and if I'll take 2 common and square is there, so it becomes 4 times x minus 3 whole square is equal to 20. Now it is x minus 3 square, so it becomes 5 times x minus 3 whole square is equal to 20, or from here we can see it is x minus 3 whole square is equal to 4, and hence x minus 3 is going to be plus minus root 4, that is plus minus 2. We will take plus minus both, and hence the x coordinates would be with plus sign 2 plus 3, and with minus sign we will get minus 2 plus 3. So that is 5 comma 5 here, and it is going to be 1. So x coordinates of C, which was on the latter part, so x coordinates of C is 5 and x coordinates of D is 1. So I hope it is clear. Let's do the next question. Here is question number 10. The diagram shows a sector CAB which is part of circles with center C, and this is an arc ADB, and this is a sector. A circle with center O and radius R lies within the sector and touches it at DEF, okay, where COD is a straight line, and angles ACD is theta. Find CD in terms of R and sine theta. So O is a center, so this part is R because it's a radius. Now we require CD, so all we need to get is this length, and we know the angle between the tangent and radius at contact point is 90 degrees, so it is 90 degree. Now we have a right angle triangle, we can see, and this is hypotenuse, so this is C, it is O, it is F, and this is R, and this angle is theta. So we can find OC. OC is going to be, so for this we'll use sine theta. So sine theta is equal to R over OC, and hence OC, that is hypotenuse, is equal to R over sine theta. And now if we have OC, we can get CD directly in terms of R and sine theta. CD is OC plus OD, that is R over sine theta plus R, or we can write it as R times 1 over sine theta plus 1. So that is the CD in terms of R and sine theta. We can simplify it further also, that we're 1 plus sine theta upon sine theta, and here R, but that's fine. So that is the answer for this. Let's do the B part of it. And here is the B part. It is now given that R is equal to 4 and theta is equal to pi by 6. Find the perimeter of sector CAB in terms of pi. So I brought this figure here so that we can see what we are finding. So from the previous part we had CD is R times 1 over sine theta plus 1. If we put the value R as 4, sine theta means sine pi by 6 is 1 upon 2 plus 1, so it become 2 going up in numerator, so 2 plus 1 3, 4 is 12. So we have CD as 12. Now we know that it is a sector, so we have CA is equal to CB is equal to CD, that is a radius, and now these all are 12. And so in order to find the perimeter, we require ADB arc length, and arc length is r theta. So this is theta, so total become 2 theta, and 2 times pi by 6, this is theta. R is given by 12, CD is r, so it is 12 here. So altogether we got 6 2s are, so 4 pi, and hence perimeter would be, perimeter is equal to 4 pi plus 2 times radius, that is 2 times CA 12, and hence it becomes 4 pi plus 24. That is the perimeter. This is the perimeter of the sector CAB. Let's do the next part. Here is the C part. Find the area of shaded region in terms of pi and root 3. So now we have theta as pi by 6 given. We need to find, and radius is 4. So if we require this shaded region, what we will do, we'll find the area of, and we can see these two COF and COE both are same triangle, congruent triangle, and hence if we can find the area of this triangle, we'll double it, we'll get this total area CFOE, and then we'll subtract the area of this sector, and hence we can get the required area. So first of all, we require this total angle. If we know that it is pi by 6, this is pi by 2, so this angle would be pi by 2 minus pi by 6, that is pi by 3, and hence this total angle become 2 pi by 3. This total angle become 2 pi by 3. So area of sector we'll find. First of all, area of sector is half r square theta, so it become r square, it means 4 square, it is 16. Theta is 2 pi by 3, so 2 pi by 3. Now these two got cancelled, and we have 16 pi by 3. 16 pi by 3 is the area of sector, which we need to subtract it from the area of the triangle, double of the area of triangle. So area of CFOA is going to be double of area of one triangle, and area of triangle will use the area sine formula, that is going to be 1 upon 2, two consecutive sides, that is r 4, and CO, which will be, we know that CO was from the first part r over sine theta, r is 4, sine theta means sine pi by 6, it means 1 by 2, it means it would be 8, so it become 8 into sine of pi by 3. Sine pi by 3 is root 3 by 2. So we will cancel it, 2 cancelled, 2 so it become 16 root 3, and hence required area, this is required area. Area is going to be the total area, means CFOE 16 root 3 minus area of sector, that is 16 over 3 pi. We can take 16 common, it become root 3 minus pi by 3. So that is the answer in terms of pi and root 3. So I hope it is clear. Let's do the next question. Here's the question number 11. The functions f and g are defined by this: fx is equal to x square plus 3 for x greater than 0, gx is equal to 2x plus 1 for x greater than minus half, and find an expression for f g of x. So we will write it as f of g of x. It means f of 2x plus 1, which will give us, this is the input for the function f. So the input, the function f, square the input and sum 3. so it means it is going to be 2x plus 1 whole square plus 3, means it is 4x square plus 4x by the identity and plus 1 plus 3, or we can write it as 4x square plus 4x plus 4. This is the f of g of x. Let's do the b part of it. It says find an expression for fg inverse of x and state the domain of fg inverse. So for the expression for an expression for fg inverse, I'll use this term so that I can directly take this 3 over here and I can get that. So I'll take fg of x, fgx as y. Then the first step is to convert fgx as y. So y is equal to 2x plus 1 whole square plus 3. Now we will interchange it, so it becomes x is equal to 2y plus 1 whole square plus 3. Now the procedure is to make y y subject so that we can get the inverse. Would be x minus 3 is equal to 2y plus 1 whole square, or 2y plus 1 is equal to plus minus root x minus 3. Now at this stage we need to decide whether we are going to take this plus sign or minus sign. So we can simplify a little bit more and we can get y in terms of this. So first of all, it is y is equal to minus 1 by 2 plus minus root x minus 3 upon 2. Now this is y, that is fg inverse, and from here we can see this is fg of x. So the value of the, or we can say range would be x greater than 0. So in order to get this value as greater than 0, we require this to be positive, otherwise minus half, and if you are subtracting any positive number it will always be negative. So since this fx the domain for fx is greater than 0, so it means this is the domain for fgx as well, and hence this would be range for fg inverse, and hence we can decide from here that it should not be negative. So we'll write from here fg inverse of x is equal to minus half plus root x minus 3 over 2. And the domain, we can see the domain of this, we can see that it should not be 0, and hence x minus 3 should be greater than 0, or we can say x should be greater than 3. That is the value, that is the domain. I hope it is clear. Let's do the next question. Here is the C part. Solve the equation fg of x minus 3 is equal to gf of x. So we'll write first of all what was fx. Fx is x square plus 3 and g of x was 2x plus 1. So we are going to use a composite function and we'll write the left hand side f of g of x. So it is going to be square of the input, that is square of 2x plus 1 plus 3 and minus 3 as it is, because minus 3 here, and g of fx, g of input, so 2 times input was x square plus 3 plus 1. So now we will simplify it as 4x square plus 4x plus 1, these two got cancelled, is equal to 2x square plus 6 plus 1, 1 cancelled. We'll take everything to the one side and it become 2x square, because 4x minus 2x square is 2x square, plus 4x minus 6 is equal to 0, or we can write it as x square plus 2x minus 3 is equal to 0, which can be factorized, and we can write it as x plus 3 and x minus 1. So we got two values of x, those are x is equal to 1 and minus 3. So since this fx was defined only for x greater than equal to 1 and gx all greater than equal to 0. So this is going to be only x is equal to 1. So the solution is x is equal to 1. So let's discuss the next question. Here's the question number 12. The diagram shows a curve with equation y is equal to 4x to the power 1 by 2 minus 2x for x greater than equal to 0 and a straight line with equation y is equal to 3 minus x. The curve crosses the x-axis at a 4, 0 and crosses the straight line at b and c. Find by calculation the x coordinates of b and c here. So we can see if we are finding b and c, it means they are the intersection points of the curve and the line. It means for finding the intersection point we need to make them equal. Means 4x to the power 1 by 2 minus 2x, it should be another, that is equation of line 3 minus x. And I'll transfer everything to the other side. It become minus 2x to this side become x, minus 2 plus 2x minus x is x. It is 4 minus 4x to the power 1 by 2 and plus 3. Now I'll take x to the power 1 by 2 as a, so that we got it this equation as a square minus 4 times a plus 3 is equal to 0. Now in order to solve it, we'll make this, factorize it, and this is going to be a minus 3 and a minus 1. So we will get a as 1 and 3. So we got x as, because from here we can see that x is going to be a square, so x as 1, square of 1 is 1 and square of 3 is 9. So the x coordinates of b is 1, here it is 1, and x coordinate of c is going to be 9. I hope it is clear. Let's do the b part of this question. Here's the b part. Show that b is a stationary point on the curve. So if b is going to be a stationary point, and from the first part we have seen that it is 1, so if it is stationary point, it means the gradient, that is dy over dx at this point, would be 0, and dy over dx for y is equal to 4x to the power half minus 2x would be dy over dx. The differentiation, it is going to be 4 into 1 by 2 x to the power minus half minus 2 here, so this is got cancelled, and at b dy over dx is going to be 2 into 1 to the power minus half minus 2 is going to be 2 into 1, that is 2, minus 2 is equal to 0, and hence b is a stationary point. I hope it is clear. Let's do the C part. And here is the C part. Find the area of shaded region. So I have put this diagram here so that we can see it properly, that which area we are finding. The first thing is we need to know, we can see that there are two areas, and if we know what is this point, of course it is very easy to find, because on x-axis y is equal to 0, so this would be 3, and x coordinate of c is, we have found in the first part, that is 9. So what we are going to do, we are going to find the area of the triangle, this line, so it will form a triangle, right angle triangle, and then area between the x-axis and the curve from 4 to 9, and we'll subtract that. So first of all, area of triangle, it is going to be half base, and we can see this point, it's an intersection with this, so x is equal to 9, so it is going to be 9 comma minus 6 also, so we got this length as 6. So half into base is 6, 9 minus 3, 6, and this is also 6, so you got 18. area in positive value is 18 here, and now we are going to find the area between the curve and x-axis is going to be from from lower bound is 4 to 9, because 4 to 9, and it is y dx, so 4 times x to the power 1 by 2 minus 2x dx. So it become 4x to the power 3 by 2 upon 3 by 2 minus 2x square upon 2. So this got cancelled, and 4 to 9, and hence it is 2 4s are 8 over 3, upper limit is 9, so 9 power 3 by 2, 9 power 1 by 2 is 3, 3 power 3 is 27, and minus 8 is square, so 81, and minus the lower bound, so lower bound it is 8 by 3 of course, and x is 4, so 4 root is 2, 2 to the power 3 is 8, minus this 4 4 are 16. So we'll solve this. It is 3 9s are 9 8s are 72 minus 81, and 8 8s are 64, minus 64 upon 3 and plus 16. And now we will solve this, and this answer is